Hi guys, today we're going to talk about simplifying algebraic expressions and the distributive property. And it looks like we have a lot of I can statements, but really we're just pulling out a few particular parts. We're going to simplify algebraic expressions using the properties and the distributive property. We're going to do that by combining like terms, which we'll discuss in this video, and rewrite expressions to better understand real-world problems. Let's think of a trip to a grocery store. Instead of selling apples by the pound, the grocer decides to sell them by the quantity. So each bag is going to have the same number of apples. So how can we write an expression to describe 2 bags of apples if we don't know how many apples are in each bag? Well, I can write an algebraic expression, 2a, where 2 represents the number of bags I purchase, and a represents the number of apples in each bag. In the same way, instead of selling bananas by the pound, the grocer decides to sell them by the quantity, and each bag is going to have the same number of bananas. So if I wanted to write an algebraic expression for 3 bags of bananas, but I don't know how many bananas are in each bag, I could write 3b. The 3 represents the number of bags I want to purchase, and the b represents the number of bananas in each bag. Notice I didn't use a as my variable, because the grocer might not put the same number of apples in a bag as he puts bananas in a bag. Pineapples are sold separately at this grocery store. So if I wanted to write an expression to describe 4 pineapples, I would just write 4 because I know exactly how much fruit I'm getting or how many pieces of fruit I'm getting. So let's go shopping. Your mom mentions that she needs 2 bags of apples, 1 bag of bananas, and 2 pineapples to make a fruit salad. You decide to be helpful and pick them up for her on the way home from school. So let's write an expression for the amount of fruit you purchased. Well, what do you need? 2 bags of apples, 1 bag of bananas, and 2 pineapples. So an algebraic expression for the total pieces of fruit you purchased would be 2a to represent your 2 bags of apples, 1b to represent your bag of bananas, plus 2 to represent the 2 pieces of fruit or the 2 pineapples that you purchased. Your mom's very thankful for your help, but your sister also picked up fruit, the fruit that your mom needs on the way home. So how much fruit does your mom have now? Well, let's think about what you purchased, and let's think about what your sister purchased. Note, and it's going to be helpful later on, that they are identical purchases. But if I wanted to write an algebraic expression for the total pieces of fruit at your house now, I would combine the 4 bags of apples, or the 2 bags of apples that you bought and your sister bought to get 4 bags of apples. In total, you have 2 bags of bananas and 4 pineapples. So my algebraic expression would be 4a to represent the bags of apples, plus 2b to represent bags of bananas, plus 4 to represent the pineapples. Or I could think of this problem in another way. You and your sister both purchased the same thing. So we could actually multiply what you purchased by 2 using the distributive property. When I do that, I multiply 2 by every term in the parentheses. And since I don't know what a or b is, I can't multiply 2 times a, but I can multiply 2 times its coefficient. Remember, b has a coefficient of 1. If there's no coefficient written, we know that it's actually a 1. So when I multiply 2 times 2a, I get 4a, because I'm just multiplying coefficients. Plus 2 times 1b is 2b, plus 2 times 2 is 4. So I get the same answer using the distributive property. Your dad bought 6 bags of apples and 2 bags of bananas. Your brother bought 2 bags of bananas and 2 pineapples. So let's write an algebraic expression for the amount of fruit they have altogether. Here's what your dad bought, and we would represent that with the algebraic expression 6a plus 2b to represent 6 bags of apples and 2 bags of bananas. Your brother, his purchase can be represented by 2b plus 2 to represent 2 bags of bananas and 2 pineapples. Now let's combine those by adding them together. You'll notice that you still have 6 bags of apples, but between the two purchases, you have 4 bags of bananas, and you still have 2 pineapples. So my algebraic expression would be 6a plus 4b plus 2. Let's stop for a minute and identify some important vocabulary. A term can be a number, a variable, or a product of a number and variables, like 2x. Terms in an expression are separated by addition and subtraction signs. So let's look at this expression. Everything that comes between the addition and subtraction signs, or outside of the addition and subtraction signs, are a term. So in this case, this expression has 5 terms. Notice, we said that it can be a product of a number and variables. So right here, it's actually 1/3 times x. If I were to multiply this, 1 times x is x, and 3 times 1 is 3. So 1 times x is 1x, and I don't need that 1 over 3. So really, what looks like a division problem is actually a multiplication problem of a fraction times a variable. Y does have a coefficient. It's a 1, but a variable that stands on its own is still a like term. A number that stands on its own, or the constant in a problem, is considered its own term as well. Now it's your turn. In the work section of your WSQ, rewrite the expressions 1 through 5. Then tell how many terms are in each of the expressions. Pause the video and complete 1 through 5. When you're done, hit play because we still have a few things to discuss. Now that we've discussed terms, let's now discuss like terms. Like terms are terms with the same variable raised to the same power. That's important, that it's raised to the same power. The coefficients do not have to be the same. Constants like 5, 1/2, and 3 2/10 are also like terms. Let's look at some examples of like terms. 3x and 2x are like terms because they have the same variable. Notice they don't have to have the same coefficient. W and w over 7 are like terms. Remember, w over 7 is actually the multiplication problem of 1/7 times w. So the coefficient is 1/7, and the coefficient of w is actually 1. 5 and 1 8/10 are like terms because neither of them have a variable. I can add those without any problem. Let's look at some non-examples. 5x squared and 2x are not like terms because the exponents are different. Remember, we said like terms have the same variable raised to the same power. 6a and 6b are not like terms because although they have the same coefficient, they don't have the same variables. And 3 2/10 and n are not like terms because one has a variable, n, and the other term does not have a variable, so they can't be combined. Let's look at this list of terms and identify the like terms. When I'm identifying like terms, I find it helpful to use different shapes or colors to indicate sets of like terms. So I would look for variables with like powers, like 3t and 7t. Although their coefficients are different, I'm only concerned about the variables being the same. 5w squared and 4w squared are like terms because they have the same variable w raised to the same power, 2. 9v and 8v are like terms because they have the same variable, v. Combining like terms is like grouping similar objects. So let's go back to our grocery store examples. If I have 4 bags of apples plus 5 bags of apples, how much do I have? Well, let's write an algebraic expression for that. 4a plus 5a equals what? Well, if I put all those bags together, I get 9a. When I'm combining like terms, I'm just going to simply add or subtract the coefficients of my like terms. So 4a and 5a, I'm going to add those coefficients, 4 and 5, to get 9. The number of bags changed in this problem. However, the number of apples in each bag did not, so I don't do anything with that a. I leave it the same to get 9a is a simplified version of this problem. Let's return to our fruit problem. Your mom is overwhelmed by all the fruit and wants to return some. You and your sister bought 4a plus 2b plus 4. Your dad and brother bought 6a plus 4b plus 2. So let's write an algebraic expression for the amount of fruit your mom has total. When I do that, I'm going to combine like terms. I'm going to look and say she has 4 bags of apples plus 6 bags of apples to give you 10 bags of apples. I can't combine that with bananas because the bags of bananas may have a different number of fruits in them. So I'm going to add 2b plus 4b to combine that and get 6b. Now I'm going to count my pineapples. Between you and your sister, you had 4, and your dad and your brother had a combined total of 2. So when I combine those, put those all together for your mom, she has 6 pineapples. So in total, she has 10 bags of apples plus 6 bags of bananas plus 6 pineapples. She only needs 2a plus 1b plus 2 and currently has 10a plus 6b plus 6. So how much fruit would she need to return to the store? Let's do that by writing an algebraic expression for the amount of fruit your mom needs to return. And I do that by thinking of what she has and subtracting what she needs to figure out what needs to go back to the store. I've put the like terms next to each other so that I can go ahead and combine them. I would get, when I combine 10a minus 2a, I subtract the coefficients to get 8a. 6b minus 1b is 5b, and 6 minus 2 is 4. So your mom needs to return 8 bags of apples plus 5 bags of bananas plus 4 pineapples. So to solve the previous problem, we had to combine like terms to simplify our expressions. Let's look at some more examples. In example A, 6t and 4t are like terms. So all I would need to do is subtract the coefficients to get 2t. In B, I might notice that in this expression, there are no like terms to combine. So this is as simplified as this expression can get. I leave it alone. But in C, I'm going to use some of the properties. First, I'm going to identify the like terms by either using different colors or different shapes. Then I'm going to use the commutative property to put them together and group them using the associative property. Notice 4b was being subtracted. So when I bring it down and group it, I'm still subtracting 4b. Now I can combine my like terms according to what operations I have to get 5a squared plus 1b. And since these two don't have any like terms, they stay the same in my expression. Let's look at letter A. They're like terms, so I simply add the coefficients. In B, I'm going to have to use the distributive property and multiply 2 times everything inside. I'll notice that there aren't like terms after I do that, so I am done here because all 3 terms are different variables. Let's look at C. Identify the like terms, group them using the commutative property to move them and the associative property to group them. Then add or subtract the coefficients to get 9x squared, this is 0, plus 5. Now it's your turn. In the work section of your WSQ, complete numbers, read the directions, and complete numbers 1 through 4. You can go back and watch any portion of this video as many times as you need to. Don't forget to write